Hello my dear students. In this video we are going to discuss about the structure of atom lesson class 9 CBSE. This is part first video. In this video we will explore about the structure of atom, different models of the atom, that is a timeline, and Bohr scheme. We have learned the Dalton atomic theory in the previous video, which suggested that the atom was indivisible, but the discovery of two fundamental particles, that is electron and proton, inside the atom led to the failure of this aspect of Dalton atomic theory. So it was then considered necessary to know how the electrons and protons are arranged within an atom. For explaining this, many scientists proposed a various atomic model. So let's see one by one. The first model is Thomson model of an atom. So you can see this is a plum pudding model which is explained in 1904. So according to the Thomson, he proposed that an atom consists of the positively charged sphere and the electrons are embedded in it. So you can see the red colored is the positive sphere and the negative charged particle, that is the electrons, which are present inside that sphere. So second postulates the negative and positive charge are equal in magnitude, so the whole atom is electrically neutral. So this is a Thomson atomic model. So second, Rutherford model, that is a nuclear model which is explained in 1911. So in this model, at the center, positively charged particle, that is the nucleus, and around the positively charged the electrons are there. So this theory is on the basis of gold foil experiment. Rutherford put forward the nuclear model of an atom which had the following features. The first one, there is positively charged center in an atom called nucleus. Nearly all the mass of an atom resists in the nucleus. The second postulate, the electrons revolve around the nucleus in a circular path. And the third postulate, the size of nucleus is very small as compared to the size of atom. This is a Rutherford model. Now next one, the Bose model of an atom, which is explained in the 1922. So according to the postulates of Bose, only certain spatial orbits known as discrete orbits of an electron are allowed inside the atom. While revolving in discrete orbits, the electron do not radiate the energy. So this is a Bohr's atomic model. You can see this is orbits. So these electrons are permitted only to revolve in this orbit only. They cannot revolve from this orbit. So the name indicates to orbit or shell is KLMN, where n is number of shell. The first shell n is equal to 1, 2, 3, 4. So KLMN, these are the orbits. So this is explained by the Bohr's. Now after that, in 1932, J. Chadwick discovered a neutron, which is a chargeless particle which are present inside the nucleus. So A is equal to P plus N means the atomic mass is equal to proton plus neutron. So from this equation we can calculate the number of neutrons and number of protons. An atom is composed of, that subatomic particles, and which are as follows. The first one, electron, the symbol is E minus, the charge on electron is -1. Second fundamental particle is proton, symbol is P plus, the charge on proton is positive, and the last one, neutron, symbol is N, and there is no charge. So neutron is the chargeless, electron having a negative charge, proton having a positive charge. That's why whole atom is electrically neutral. Now the Bohr scheme to distribution of electron in an atom. So you may have question that about how can the electrons distributed in any atom of any elements. So the distribution of an electron into the different orbits of an atom was suggested by Bohr and Bury. So this is a atom, this is a proton, this is a first energy level, first cell, first orbit. The name is K, is equal to 2n square is equal to 1 means the number of cell. So here will be 1, so 2 into 1 2. So the number of electron in K cell, how many electrons will be there? 2 electrons can be revolved in the first energy level, first cell. In the L, as per the formula 2n square, n is, what is n? N is 2, second cell, that's why 2 square 4, that's why 4 into 2 8. So in the second means in the L, how many electrons can be revolved? 8 electrons. In the M, as like same way 18, and in N 32 electrons can be revolved. The second rule, the maximum number of electron in the outermost orbit of an atom is 8. The maximum number of electron in the outermost orbit of an atom is 8. For example, calcium having a atomic number is 20, means the number of electron is 20. So the expected distribution should be KLM. So in K 2 electrons, in L 8 electrons, and in M 10 electrons should be. Okay, but actual distribution should be K2, then L8, then M8, and N2. Actually the capacity of M having electron is 18, but here we have to put 8, then we have to put 2 in the next. Why? Because the second rule is that the maximum number of electrons in the outermost orbit of an atom is 8. Here should be 8. Here the last orbit here, that's why we cannot put here 10, that's why we have to put here 8, then the remaining electron will go to the next orbit. Now third rule, the electrons are not accommodate in a given cell unless the inner cell are filled, that is, cell are filled in the stepwise manner. For example, correct distribution of the 13 electrons, that is in KLMN, like here 2, 7, 4, means in K2, in L7, and in M4. So this will not correct, but here K2, 8, 3. So before completed the capacity we cannot go forward. Here the capacity of L having electron is 8, so we have to put here 8, then if the electrons are remain, then we can go forward. So this configuration is correct. Now here some examples of how electrons can be distributed in the KLMN. You can see hydrogen having atomic number 1, means the number of proton 1, and number of electron also 1, so 1 electron in K. Same in the helium, 2 electrons are there, so 2 electrons will be in K. In the lithium 3 electrons are there, so 2, 1 will be here. In the carbon 2, 4 will be here. In the case of sodium 2, 8, 1. In the case of chlorine 2, 8, 7. In the argon 2, 8, 8. Such like you can say all the examples. Okay, thank you my dear students. In the next video we will discuss about the atomic number, atomic mass number, isotopes, and the valency.